Okay, good afternoon everyone. I'm going to spend about the next 15 minutes or so just briefly describing what the Scottish Energy Laboratory is, what it offers industry, and briefly describe the range of complementary and integrated facilities, testing facilities we have available to support offshore wind. It is a bit of a Scottish context and dimension, Adrian, but hopefully at the end I'll show as well how we are integrating and playing a part in that UK proposition also. First thing to add is the Scottish Energy Lab is a national remit. We're supported by the Scottish Government, key economic development agencies and key research organisation. And as Adrian highlighted, we provide an easy, single point of entry for businesses into Scotland's key energy test and demonstration assets. Wrapped around that, we have very comprehensive innovation support, grant support, market insights, technology insights, links into customers, etc. And we also have links into a very capable supply chain that's eager to develop additional business relationships. In terms of the facilities, key tests for inclusion in the Scottish Energy Laboratory are the facilities of national significance and open for industry to utilise. And I should stress that's wherever you are located. This is a Scottish initiative funded by the Scottish Government, Scottish Enterprise, but we're open for business regardless of where you're located in the globe. We currently have 44 facilities in the Energy Lab, around about £250 million invested in those facilities, so a significant capability. The blue dots, you'll not make out the numbers, but the blue dots on the map represent those facilities. You can see a wide geographical spread and clusters in and around areas of high population density. We cover all our key energy sectors, but naturally, in Scotland at the moment we have a focus on offshore renewables, and today I'm going to pick up on the offshore wind proposition. An additional offering we make to industry is access to university expertise, and just fairly recently we've integrated the Scottish Energy Laboratory with what's called the Energy Technology Partnership and a new knowledge exchange network. Now, for those who are unfamiliar, the Energy Technology Partnership is one of Europe's leading research pools, accesses 12 independent universities and roughly about 250 energy researchers. So we pooled resources and we've been able to secure additional funding, and we have around 13 full-time bodies now supporting industry, understanding where they are in energy technology development and able to bring in relevant expertise and test facilities. And I should add, if you're a Scottish SME, there's a bit of additional support, grant support, available through that new programme, which we'll touch on at the end. So in terms of our offshore wind facilities, this diagram is a very simplistic way of representing the key offshore wind facilities that we have, and it places them in the technology development process. There's various ways of describing that process. I've used here what's known as technology readiness levels, or TRLs, moving from one early stage concept through to deployment at 9, and it basically takes you through a sequential approach through concept validation, prototype development at scale, full-scale prototype into demonstration. Now, testing and validation facilities and infrastructure are required at each of those phases to validate technology, de-risk technology, attract further investment to take you to that next and inevitably more costly stage. Now, right away you'll see quite visually that we have a lot of facilities focused on that early stage of technology development for offshore wind, and there's an obvious gap there in terms of full-scale demonstration facilities, and that's both onshore and offshore. I've highlighted also some planned facilities, and I'll touch on some of them that are in development, various stages of development, including Ian's described our key offshore test facility, the European Offshore Wind Development Centre. As I say, I'll touch on a couple of the other ones in a minute. But what I wanted to do was just take you briefly through a few of those key facilities, describe them not in a great amount of detail, but just to give you a flavour of the range and type of facilities we have. And I'll move from that concept validation through to market deployment. So first up, we have significant wind tunnel facilities able to operate at that concept validation phase. These facilities are geographically based in Glasgow. For those of you who know Glasgow, the West of Scotland Science Park, just next to Maryhill, and they are operated by Glasgow University, who have extremely significant aerospace and aerodynamic expertise. They're very active in renewables at the moment, both in terms of wind and tidal. A range of wind tunnels are available, the largest of which is a working area of 9 foot by 7 foot. It's able to get wind speeds of 70 metres a second. And for those of you involved in the sector, that equates to a Reynolds number of around about 4 to 5 million, which is quite respectable in terms of wind tunnel facilities. We've done a bit of development work in there, and we're currently calibrating that facility just now, and about to do some test work on a major turbine OEM's aerofoils. This is an area that's proven to be quite difficult in terms of companies getting access to current wind tunnel facilities, especially at an economic cost. So this is what we feel is a valuable addition to that and a cost-competitive addition to that infrastructure. We also have a suite of marine test tank facilities which are actively involved in offshore wind development at that concept validation phase. Involved in projects, for instance, looking at concept development validation for vessels, access systems, foundation designs, installation techniques and methodologies, a range of facilities and a range of capabilities. Top right there we have the Kelvin Hydrodynamic Facility, which is located, interestingly, just next to the wind tunnel. It's operated by Strathclyde University. It's a 76-metre long facility and has a tow and carriage capability as well. Bottom left we have Heriot Watts Wave Basin. An interesting aspect to that is it's got a 5-metre deep pit, which is quite unusual. And last but certainly not least, the new addition to our suite of test tanks is the Flowwave facility at Edinburgh University. Globally unique facility, unique circular design, and it combines current simulation with wave simulation. And that circular design allows it basically to simulate NEC state. It can orientate the current 360 degrees and orientate the waves 360 degrees also. Moving on into subsystem component testing at scale, we have a range of facilities that you saw from that initial diagram, two which I'd like to highlight. One on the left-hand side, there's the Centre for Advanced Condition Monitoring, based up in Strathclyde University. We're currently commissioning a 200 kilowatt drivetrain test rig, which will be available to develop sensors, condition monitoring systems, and take that to market. We've signed up some initial industrial partners, but we're very keen to hear from others who may be interested in that area. On the right-hand side, we have the Energy Technology Centre, based in East Kilbride, provides a range of sub-megawatt test rigs and capability to test its subsystem and do highly accelerated lifetime testing on key critical components. A project we're currently working on just now is developing a blade erosion rig. This is based on some initial research and modelling work at Strathclyde University, which we're now developing a physical rig to test that model and also to look at testing and validating erosion mitigation technologies on blades. Again, we've got some industrial interest in that, but very keen to hear from others. Moving on to full-scale testing, here we have our wind turbine test site at Myers Hill. Those in the industry will be well aware it's got quite a pedigree in the industry. Wealth of R&D, research and development and testing that's went on over the years there. Latterly, there's been quite a lot of interest and activity in small wind and medium wind. The picture on the left, you'll probably make out some of the small wind devices, but it's still very active in large wind. There's two 950 kilowatt turbines on that site, and we've been using them recently to test and validate subsystem technologies that play into offshore wind. Two examples of that, one on condition monitoring, looking at structural health monitoring systems, and being able to assess the performance on that turbine in an operational condition. And also quite a lot of work going on in wind measurement technology, specifically LiDAR, or using lasers to measure wind. A couple of elements to that. There's two projects we're working on just now, research projects. One is looking at using LiDAR to analyse and understand better wake effects and build that into a robust model using computational fluid dynamics, or CFD, and using the actual turbine measurements to validate that model with a view to improving an understanding of wake effects and also how to optimise turbine configuration in wind farms. The second project worth highlighting, you probably just make out on the turbine on the right-hand side there, we've got a LiDAR unit mounted on the cell and actually pointing towards the wind. The LiDAR is actually scanning and looking at how wind velocity varies over large rotor diameters, so looking at wind shear and wind veer over a rotor area. That's feeding into an improved understanding of how to develop power curves, but also feeding into future design standards. And we're just about to instrument the turbine to understand how the wind is affecting loading on the turbine. So we're going to combine those more refined wind measurements, seeing what the wind's like when the wind structure hitting the turbine, understand the loads with a view to improving and optimizing control to improve turbine performance and reduce those potential damaging loads. Moving on, next stage is looking at testing and certification of offshore turbines onshore. It's well known there's a lack of competition in the marketplace. This is part of our efforts to try and address this by proving, testing, certifying more technologies and also developing supply chain links. Now, this is a project that Scottish Enterprise are developing in partnership with Scottish and Southern Energy. It's based at Hunterston on the west coast of Scotland, and it's a 3 test berth facility. 2 of those test berths are controlled by Scottish and Southern, and they're about to start testing on them this year. The 3rd one is in our control. We've went to the market, we've got interest from the market, and we're about to do some consultations with the market to understand, over and above the testing, what can they deliver in terms of supply chain impacts and also engagement in our R&D efforts, because that will be a major factor in deciding who gets access to that site. And the last project I'll mention, some will have seen the press release on this, but this is a couple of photo montages of the Methil test site where Samsung are about to test their new offshore wind turbine, their 7 megawatt turbine. It is offshore turbine, but it's just offshore. I think it's about 30 metres offshore. But again, I think a great example of the Scottish Government, Scottish Enterprise getting behind the efforts to provide infrastructure to test additional turbines, new designs, open up that marketplace and secure supply chain impacts. So back to the slide where I showed the offshore wind facilities we have, again, clustered around that early stage, but hopefully I've shown efforts we've got to work at addressing those gaps. I should add that we're working with colleagues at a UK and an EU level to try and understand how we can pool resources and coordinate this agenda. And I've highlighted 3 facilities from NARIC, the New Renewable Energy Centre. We're working very closely with NARIC at the moment. Yes, this is a Scottish energy lab funded by Scotland, but we are working at genuinely working at an integrated UK level through the new offshore renewable energy catapult, which NARIC are heavily involved in. So it is a Scottish dimension. We will play the Scottish card, but at offshore wind, rest assured, we are working together to provide this integrated offering of test and demonstration assets for the UK. So in summary, wherever you are, doesn't matter where you're located, if you are developing energy technology and interested in support to access our key energy test assets, energy research expertise, or wealth of innovation support, and again, I highlighted it previously, if you're a Scottish SME, for a limited time only, through this additional funding, we can offer 15 days free consultancy or up to 5K testing support. It's small scale, but it might just get you started in early prototype development testing. If you're interested in any of the other projects I highlight, please feel free to contact me at the details below, or talk to myself and colleagues on the Scottish Enterprise stand at H41 or the Energy Technology Partnership stand at F80. Thanks for your attention.
Thanks very much, Terry. When I introduced Terry, I said that single point of entry. I think that's really a really important point. I think the UK generally could learn from that. When I look at what's happening south of the border, I don't see that kind of joined up thinking. That first slide that Terry showed about pulling in all of the various things around that hub, I think that's a very clear model, and it makes it much easier for companies to engage and understand what's available, how it can be accessed, what the funds are, what the processes they have to go through. I think the other thing that I took from that was the importance of onshore full-scale turbine testing in that route to commercialisation. We heard from Ian about the offshore one. The onshore bit is just as important in the way that turbines are currently brought to market. And I think also, finally, that learning from that within the UK, working with the offshore renewable energy catapult, and possibly even with European entities, because at the end of the day, this is a European endeavour. We have the best wind resources, not just in Scotland, in the UK, but in Europe, and actually it doesn't make sense for us to be all reinventing the wheel when it comes to learnings and test and demonstration. I also think it shows that how such a network and support through those technology readiness levels can help companies. And I think that's perhaps best demonstrated by our next speaker, who's